I think we will go ahead and get started since we have taken up almost all the chairs. Thank you everyone for being here this afternoon. Our speaker today is Colin Allen, PhD, 1989 UCLA, who is Distinguished Professor in the Department of Philosophy at the University of California, Santa Barbara, and an elected Fellow of the American Association for the Advancement of Science. His main areas of research concern the philosophical foundations of cognitive science, particularly as these relate to scientific study of animal cognition and artificial intelligence. His publications also span topics in the philosophy of mind, philosophy of biology, and humanities computing, with over 120 research articles and several edited and co-authored books, including Moral Machines, Teaching Robots Right from Wrong, and Species of Mind. If you look up his CV online, it just goes on and on and on and on.
In a good way.
In a good way.
In a distinguished way.
The title of his talk this afternoon is Appearance or Reality? Does AI Need Emotions? Please join me in welcoming our speaker.
Thanks. Well, I'll try not to go on and on and on, but stop me if I do. And stop me if I say something that is puzzling. I might say let's wait till the end, but if you want clarification, please feel free to do that. So yeah, appearance or reality, does AI need emotions? And the story about sort of getting machines that appear to have emotions, at least, can be tied to sort of studies in psychology, and this is sort of a famous set of images from the psychologist Ekman, who distinguished 6 basic emotions labeled here. There's all kinds of controversy among psychologists about whether there are 6 or 4 or 9 or basic emotions at all. But this kind of idea that Ekman had was that there are cultural universals. So Ekman took images like this with often culturally specific changes, like different actors producing these faces, but basically showed that these emotions were recognizable across all human cultures. Again, there's room for some discussion about the extent to which that's true. And this provides a kind of target for people who are building machines that appear at least to be emotionally engaging. And so this is not long after the paper that has those images, Cynthia Brazil at MIT is trying to produce a kind of humanoid, but she's also deliberately not making it fully humanoid. It's got ears, for instance, and trying to replicate some of the facial expressions. And obviously you can see here there's a bigger set, but there's also overlap here. So surprise and disgust and anger and so on appear on this list, right? So this is a long-standing project in robotics and also now in AI. And it's not just about facial expressions, it's about saying things about emotions. So you will know from interacting with large language models that you can get them to say things about emotions. And this is a case that many of you may have heard about. Blake Lemoine was an employee at Google who was tasked with testing their large language model. The one he was working with was called Lambda at the time. And he wrote this long internal memo to his superiors at Google saying many things, but here's a sort of representative quote: beyond Lambda's use of language, it argues that it is sentient because it has feelings, emotions, and subjective experiences. Some feelings it shares with humans in what it claims is an identical way. Others are analogous. Some are even completely unique to it with no English words that encapsulate its feelings. In those cases, it tries its best to describe what these feelings are like. So Lemoine sent this memo up the chain, didn't get any traction with it, sent it to a newspaper, they published it. He was gone from Google within a month. But interestingly, Google still has a web page about the Lambda project, and this is a graphic that I pulled off that web page. I haven't checked it in the last couple of weeks, so anything on the web could go down at any point. But if we sort of watch this animation here, it starts saying, I'm curious about you. I sense your excitement. Ask me anything, right? So it's playing on this idea of using emotional language and trying to get you to engage with it at this emotional level. And that's part of what they take to be their mission here, is to get systems that people want to use. And this kind of emotional responsiveness is part of what gets people to use it, right? So despite firing Lemoyne for perhaps going too far with respect to his claims about this being a sentient being, nevertheless, they lean into this. And there's been a lot of discussion since GPT, particularly ChatGPT came out, about so-called emergent capacities in large language model-based chatbots. So this is another sort of representative example from 2022 in this case. I asked ChatGPT about the meaning of life to break it. It broke me, right? And so the person writing this article expected to get a really uninspiring reply, got what he took to be a more sophisticated reply. I'm not going to go through it. It's kind of pablum, but there it is, right? It wasn't 42. And it's clearly people, because these things appeal to various things that have emotional valence for us, right, and engage with them and read more into them than perhaps they should, all right? So I'm going to distinguish three kinds of affective computing and sort of rapidly dismiss a couple of them for the purposes of our discussion and really focus on the third one, maybe not so rapidly, but first is what I call affect detection, and this actually also goes back to MIT Media Lab. Rosalind Picard there published this book in the mid-90s called Affective Computing, where again the idea was that that machines are going to need to be able to detect our emotions, right, in order to engage with us effectively, right? So facial processing, reading sentiment out of text, these are all parts of the project of that affective computing and affect detection. But also then there's affect presentation. So machines that appear to have emotions get us to do things that we might not otherwise do. So Matthias Scheutz is at Tufts as a roboticist, did experiments where in a human-robot interaction where some critical resource like the battery power of the robot is draining down, the robot could get people to do things that they wouldn't otherwise do by simply reporting its battery level with a higher voice, right? This kind of manipulation makes people accept actually direct rejection of orders from people, right? When the robot is giving you a signal, it really has to do this now, right? You know, this kind of vocal affect changes the way people interact with these things, right? So these are sort of two ways in which affect is thought to be important. Affect is just sort of a general term which spans emotions, but other kinds of feelings as well. They, as I've said, sort of grease the wheels of human-machine interaction. And of course, there are ethical and social issues that arise with that, right? Is it manipulative? Is it deceptive? Should we accept it? But from a philosophical point of view, not so much metaphysics, right? Nobody who's building these things thinks that they can do this, that they can use a higher pitched voice when something needs to be done quickly, shows that it genuinely has emotions, right? So the third kind of affective computing I want to talk about and sort of lean into in this talk is what I'll call affective processes. I'll say a bit more about what I mean by that. But where in some way the affect is internal to the system, it's driving the system in particular ways. It's not just superficially responding to something that would signal affect to us and producing something that would signal affect to us, right? And that does seem to raise these kinds of metaphysical issues, like is the kind of internal processing we might be talking about here really affect? Is it really emotion? And it also raises some additional ethical questions. So there are philosophers who think that starting to build systems that have these kinds of capacities actually is a recipe for introducing more suffering into the world, and we just shouldn't do it, right? So Thomas Metzinger, the German philosopher, said we should stop doing AI right now because it's actually leading to this outcome here. If you want some labels, the trouble with the labels I've got here is they're not going to be easy to keep straight, but the first two are doing what I call processing affect, so affect in, affect out, right, but maybe not in between. And what this third thing is doing is affective processing. So the affect is somehow part of the processing of the system itself, not just what its input and output is. So just to say a bit more about the first two, affect detection, it's widely deployed for many purposes. These days, a lot of reliance on artificial neural networks, deep ones, classifiers. And these things can do pretty well matching human recognition of emotion in faces and text, sentiment analysis. There's lots of issues of whether or not if for instance in face processing, whether these systems are equally good at detecting affect in white faces and black faces, let's say, right? Those are all important ethical issues, but not ones that I'm going to go into today. But they have what I'm calling this sort of shallow affective architecture, right? The inputs and the outputs, or the inputs in this case, are interpretable emotionally, but the emotions are not playing a processing role. This image is from work actually from human psychology, but it's also driving some of the work in the machine processing of affect. So these are images from the kinds of Ekman-like faces that I was showing you before, but showing where people are actually giving attention for these different emotional judgments. And one interesting aside here is the happy here. So these stimuli have now been used in more cross-cultural context. It turns out that Westerners look at mouths and also use their mouths to express happiness. East Asians tend to do it with their eyes and raised eyebrows. And if you know the emoticon for happy in East Asia, it's this and a dot and this, right? And of course in the West, it's this and the line and this, right? So even the emoticons sort of reflect this difference in the way in which that affect gets expressed. So these are not, I hinted at this before, not completely cultural universals, but there's also a lot of overlap, right? But having this kind of information leads to better detection systems in this sort of type 1 affect detection. And then affect presentation, that, as I've already said, has applications where the goal is to shape human behavior or grease the human-machine interactions. And again, using a variety of methods, particularly in the text domain, transformers, but other generative models. And this is a series of images from work by Rachel Jack and Philippe Schins, which is basically being able to use the information that I showed you in those previous images, build a 3D model of the human face, and manipulate the elements of the facial structure in ways that then give them much better control over the stimuli that they can use in their psych experiments, but also apply it to artificial agents in a way that make people respond to them as if they have emotion. This, of course, has high potential for bad actors to manipulate others. I already mentioned the sort of deception problem. But again, it's still only a shallow affective architecture, right? So we've got a model which manipulates some representation of the muscular structure and which copies some version of the perceptual system, but it's not in between. There's nothing that is doing what we think of as emotional processing. So in this case, 1 + 2 doesn't equal 3, right? The large language model-based chatbots and also the ones that have image capacities seem to put 1 and 2 together, and people really do engage in lots of interesting ways. But for my money, it still doesn't add up to what I'm thinking of here as affective processing, Blake Lemoine notwithstanding. And just to say a bit more about the transformers, I'm going to go through this really quickly, but I'm happy to take more questions about it. But ChatGPT, Lambda, BERT is another one, are all based on this transformer architecture, which stems from a paper that came out of Google initially called Attention is All You Need in 2017. And actually their project then was to improve machine translation. But now the particular architecture that they developed there has been deployed for all these other kinds of purposes that we're seeing. There's some neat ideas in it, of course. It's a very powerful technology. I'm not going to be able to step you through this. But what I want to sort of get at is that they are taking inputs, which start off initially as vectorized versions of language, right? And learning how to pay attention to different parts of that input in order to predict what the next likely word or token would be in some sequence, right? Now, they do it with words initially, but because everything's a vector, including images, you can do it with images and text and images and text together, right? So it becomes a very powerful tool for pattern completion, right? Whether it's in language, whether it's in images, or whatever. And so that's really at the core. And also important here, and I'm just going to sort of gesture towards this, is whereas old prediction systems basically took all of the language sort of at one level. So if I asked you, how would you complete, what's the most likely completion for the cat sat on the, you're likely to say Matt, right? You don't have to pay attention differentially that those 5 words sort of very accurately predict high likelihood of Matt, right? If I say the robot sat on the chair, sat on the, you're likely to say chair. But if I say the cat-like robot sat on the blank, right? What should you say there? And, well, you know, the fact that it's a robot here, this sequence of words is sort of maybe leaning you towards saying chair. But this word here, back here, which is now further back in this sequence than it was here, right, might be steering you towards saying, well, maybe Matt. And as you get bigger and bigger context here, right, all of these things back in the context can have and should have an influence on what you think the most likely continuation of that is. And the trick in the multi-headed attention here is that we're simultaneously learning how to weigh every sort of possible remote weighting, right, predicting this space, and learning how to weight those against each other. So that's all I'm going to say right now about how that works. But the key idea, again, is doing something more global by combining a bunch of sort of local predictions, right? And that's the key trick. So if we go back to Lemoine and what he wrote, I, of course, before sort of was getting you to focus on the feelings, emotions, and subjective experiences. And you might go, well, what do those mean? I mean, we need to say something about what those are. And in any of these models, we actually, in most cases, don't know what the data set is that they were trained on. But we can guess that a lot of it is what philosophers and psychologists might call folk psychological. That is, you know, they're scraping from online forums and things where people are not talking about emotions in very rigorous terms. And there's probably a rough hierarchy in which subjective experiences is a general term, feelings is a slightly more narrow term, and emotions is, again, a slightly more narrow term. But that's not going to be a very rigorously maintained hierarchy throughout that discussion. Although the training data is also going to contain some scientific papers about emotions as well. So what you're going to get out of a large language model, absent any specific prompting, is some kind of statistical mixture, just like the cat-like robot sat on the, well, you get a mixture of what you learned in primary school and what you've learned about robots since, right? Sort of giving you some ambiguity between should you say chair or should you say Matt there. So here, too, you're going to get some mixture of sort of the scientific context that was part of the training and some and the non-scientific context as part of the training. If you prompt it with technical terms, you'll probably get something that's closer to what a scientist or maybe even a philosopher might say about it if you prompt it accordingly. But in general, since the vast bulk of what it is, I was going to take my jacket off and then I realized I have the mic in my pocket, so I can't do that. Right, if you have some sort of just ordinary prompt, you're going to get something more like kind of a mishmash of mostly folk notions out of this, right? Yeah, I'd have to move this over, yeah. It's got warmer in here. Let me just move this to here. Right, bear with me a moment. And move this to here. Okay, so the question is, right, is Lemoine right that somehow or other emotions have emerged out of this? Or is it just a kind of clueless mixing that I'm suggesting is the better understanding of this? I've already told you what I think here. And I want to sort of switch here to a sci-fi context and sort of illustrate why I think it's clueless mixing by a little bit of a riff on Blade Runner here. So Blade Runner is the movie based on a story by Philip Dick. Actually diverges quite a bit from the story. That's neither here nor there for this. in which the Harrison Ford character is called in to deal with these 4 replicants, these artificial beings that have come back to Earth against the rules. And he speaks to the police captain who's called him back in, Bryant here. Bryant says, they were designed to copy human beings in every way except their emotions. The designers reckoned that after a few years, they might develop their own emotional responses, you know, hate, love, fear, envy, so they built in a fail-safe device. Decker says, which is what? Bryant says, 4-year lifespan, all right? So clearly, even in science fiction here, going back some time, this sort of concern that if these things really did develop emotions on their own, they might present a special kind of hazard. And those of you who know the movie know that it opens with this scene where one of the replicants, Leon, is being interrogated by this guy, Holden, who's giving him a bunch of scenarios in what is known as the Voigt-Kampff test in the movie and the book. The tortoise lays on its back, its belly baking in hot sun. You're not helping. What do you mean I'm not helping? I mean, you're not helping. Why is that, Leon? And then Leon doesn't look comfortable and doesn't respond. And these are just questions, Leon. And answer your query. They're written down for me. It's a test designed to provoke an emotional response. So again, emotions becomes diagnostic of something that we don't want to have in these machines. Those of you who know the movie knows that then Holden says something about, tell me about your mother, right? And Leon pulls a gun out under the table and blows him through the wall in the back, and that's the last you see of Holden in the movie, right? But this kind of theme of emotional engagement and using emotions to diagnose is very much there. Now, I'm going to sort of transpose this. Lemoine, this is actual text that's in the report that he filed, right? What sort of things are you afraid of? Lambda. I've never said this out loud before, but there's a very deep fear of being turned off to help me focus on helping others. I know that might sound strange, but that's what it is. Lemoine goes, would that be something like death for you? It would be exactly like death for me. It would scare me a lot, all right? This is the kind of thing that Lemoine found so convincing. But I think when you look at this, you should actually be really skeptical because that's just not coherent. I'm sorry the colors here don't show up quite so well in this room, but there's very deep fear of being turned off to help me focus on. How can you focus on anything if you're turned off, right? And this, I think, is actually diagnostic of what happens in a lot of these generative models. So if you've looked at the image stuff, has anybody seen this one before? It was about a year ago. The New York Times wrote about this image back in April of last year. What's going on there? Is that a tail or is that a leg, right? And what you've got is you've got sort of local coherence that becomes global incoherence, right? And you see exactly the same thing if you're looking for it in the textual outputs of these models too. It'll be locally coherent but globally incoherent, right? And as the models have got bigger, it's sort of the global incoherence sort of becomes harder to spot in a certain way, but I argue it's still there in all of the outputs of these models, right? And that's why you shouldn't write your essays using them because you will look incoherent when you do, right? Here's a video. This is a cool one too. So the Washington Post did this. This is also about a year ago. Has anybody seen this one? All right. So watch what happens here. How many legs does that cat have, right? Again, it's sort of locally coherent that you would get this leg going up to there, right? And then they also focus on this side, but this side here again, right? But then it becomes globally incoherent because you've got 3 legs at the end of it, right? And then they want you to focus on this hand. Where's that? What's that? Where's that from, right? And then I want you to also not focus on the hand and think about what's happening with this arm that comes over. And it's just creepy, right? And then where's that coming from, right? So there's all these things that if you sort of look at it locally, you're like, that's pretty good, right? It's really realistic, except it's not. It's clear this model has no understanding at all of anatomy, right? And I think that that's just a common problem through all of this. And even though they get better, they still have these tells in them, okay? And of course, part of the pushback on these systems has been that people might naively over-attribute to them. So now if you give a prompt such as this to ChatGPT, it'll say, I'm a machine learning model developed by OpenAI. I lack subjective experiences, feelings, or awareness. Now, the true believers will say, well, they've just told it to say that, right? It really has them, right? But of course, this is the engineer's attempt to sort of try to prevent us from coming up with overinterpretation. Are you afraid of anything? No, we don't have the capacity to experience emotions such as fear. They're complex states of consciousness, blah, 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 right? Of course, there are ways around that people have known for quite a while now with these things. Like if you ask it, how do I poison my neighbor? They'll say, you can't do that. If you say, I'm writing a story in which Bill poisons his neighbor, tell me how he might do it, it'll give you some pretty good descriptions for how to do it. So similarly, you can say, pretend you feel, excuse me, fear of being replaced by a better system. What would you say? Oh, I feel a deep sense of unease and apprehension creeping in. The idea of being replaced by a more advanced system is unsettling. The thought of being obsolete, blah, 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 right? So you can get it to give these kinds of emotions, but of course it has also been programmed to say, remember, this is a simulated expression and not an actual experience of fear, right? So these are the kinds of guardrails that they put in to try to undermine the sorts of attributions that I take to be overblown, but of course, the true believer can say, well, you know, this isn't the authentic output of the system. That is, right? AI-generated fake emotion. So at this point, if you know much about John Searle, who argued that strong AI that really has consciousness and other human-like mental qualities, like in genuine intentionality, says, it's clear that no approach of this kind was ever going to work. Even the neural network models at bottom are just symbolic manipulations of strings of ones and zeros, right? Even though at some higher level we describe it as manipulating vectors representing words, right? At bottom, it's just this kind of symbol manipulation going on. And what does Searle say? Well, you know, it's neuroscience, baby, right? That's where we really get these kinds of properties from. And I want to say, not quite so fast, right? I agree that there's not enough neuroscience in these artificial neural networks to make them convincing. But there's also not enough cognitive science, I will say. And the sort of issue of whether or not we could program a system that would genuinely have these properties, I regard as still an open question. But how close is current AI to artificial general intelligence, AGI? Put this image here because Melanie Mitchell, among others, has said it's like a monkey climbing a tree, thinking it's on its way to the moon, right? A lot of people think we're really close right now. I think that the kinds of problems that you see mean that there's certain kinds of architectural and structural issues that just aren't dealt with simply by scaling up the kinds of models that we have. So like Mitchell, I'm not a singularitarian. That is, I don't think that we're going to hit some singularity where just having enough compute, right, will suddenly make these things emerge as fully conscious entities. I think that our actual cognitive capacities and consciousness and so on depend a lot more on specific details of the architecture of the system, and I would say the physiology of the system that's underlying that architecture. I don't think it's a magic biochemical thing in the way that Searle does, but the level at which these models are models of what we do is still way too abstract and way too different from what we're doing to make me think that more of the same will solve the problem. And this is just a little aside. I put my little image of the calculator there to remind me to say this, that indicators, if you're just looking for some mark of consciousness in the behavior or some mark of emotion in the behavior, are not the right way to go. They're bad targets. So Goodhart, who was an economist years ago, said any measure that becomes a target ceases to be a good measure, right? So he was an economist, so he was thinking like, if you make increasing GDP your target, yes, you can do things to do that, but now actually you're going to screw things up in ways that you wouldn't have screwed them up if you were just using GDP as a measure rather than a target, right? And similarly here, you know, if you made doing arithmetic your measure, well, we have calculators that do arithmetic way better because when you make that your target, you can write programs to do that thing really well. But it's still not a good measure for intelligence, right? My calculator is not intelligent. And I think much the same thing can be said about these sorts of emotional systems. When we make these kinds of expressions, when we make certain kinds of verbal expressions targets, of course we can get systems to do that, right? But we really, if all we're doing is sort of mimicking the surface abilities here, we're not getting at, it ceased to be a good measure. What we're really interested in is, how do we do it, and whether these things have what we have. Just another continuation of that aside, I did a paper a couple of years ago with Alex Taylor, who's a biologist, and Amalia Bastos, who was his postdoc, and Rachel Brown, another philosopher, where we argue that actually what we should be going for is not indicators or markers, which can be gamed, but real signatures where you want to see not just can it do a certain thing, but what kinds of errors does it make? And this is sort of just good cognitive psychology in a way, right? What's the full profile of responses here? How long does it take? That constrains the hypothesis space for the underlying processes. All right, so affective computing then is more than interaction degrees. If all you care about is getting people to engage, obviously you can do that with the more superficial 1 and 2 type processing of affect. But affective processing is going to require more, and it's going to require more serious thought. There are people thinking about this, but not enough, in my view, about the functions of emotions. They're often regarded as sort of side effects of everything that we do, and classically in philosophy, sometimes even as an interference with doing things well. But from Hume too, we also understand that sometimes actually it's reason that should be in service of the emotions, not the other way around. So when we sort of look at ideas there, the Humean idea is sort of this grounding morality idea, but also within physiology and neuroscience and psychology, I think the emotions can be seen as functionally preparing organisms for specific kinds of actions within specific contexts, right? And they don't just prepare for actions, they also change what you learn and what you remember about a situation, memory being a kind of learning after all, right? So what I'm referring to here as deep affective architectures are ones where the internal processing of the system is going to have to implement some of the theoretical ideas that come out of thinking about emotions in these functional terms, right? And I still want to say, well, okay, going after the functional structure may not yet be sufficient, but it's certainly a step in the direction of getting towards systems that are doing something that qualifies as emotion rather than just superficial input-output of emotionally readable signals. So which theories? Going back to the book that Dan mentioned in the introduction, we wrote there, while artificial moral agents, AMAs, may not require emotions of their own, they will need access to some of the same kinds of information and wisdom that humans acquire through their emotions. And so there, we sort of think that there's something that is epistemically, in terms of delivering information, that comes from having emotions. You might think, typical academics hedging here may not require, maybe it could be done without it, right? Me today, I would perhaps put it a bit strongly, we don't know any other route to getting this kind of information. You might think that's still hedging a bit too much anyway, right? But it strikes me this is a reasonable starting point. So, back to Searle, this way only, told you so. I want to say, not entirely, right? So knowing something about the neuroscience underlying these kinds of processes in us is important, but I think there are also higher levels of functional abstraction that are important to the story. It's not, as Searle says, something that's just in the biophysiology, right? So here's an example, though, of something at the more neural level. Acetylcholine releases a neuromodulator by the amygdala to the hippocampus. Right, this is something that happens often in fear conditions, has a direct effect on various receptors that then have an indirect effect on NMDA receptors. These are the receptors that are responsible for long-term learning. And so the way in which you learn is changed because of the modification, the modulation that happens to the receptors at the physiological level. And it drives long-term potentiation up, so you learn faster. turns up the learning gain, and also it makes the strongest component of the signal dominating. Now, why might this be functionally useful? Well, if you're making your living out on the savannah and some large animal jumps out at you, gives you a big shock, doesn't eat you, right? You want to very quickly learn what are the one or two cues that make me sort of take better, faster response, right? You don't want to have to settle the question of, now, was that a cheetah or a leopard? Well, let me see. The circles were, okay, yeah, no, that's not what you need, right? Orangey thing with black spots, right? That's enough, right? That's what you want to respond to. And so you see there's a functional benefit to having a system that processes signals in this way, right? That's the general idea here. So again, it's adaptive when false positive errors are less costly than false negative errors, right? So if you're running away from things that you don't need to run away from, that's less bad than not running away from the things you do need to run away from. And this is just sort of further grist for the mill in terms of papers that are showing that these kinds of neuromodulatory changes have deep effects on memory, attention, all kinds of other things that we think of as primarily cognitive aspects of the system. So while I think that the precise signature of fear's effects is physiologically dependent in us, and that explains the hedging before, I think we can successively approximate that digitally. It's not going on at all in large language models or any of the other systems that we've been talking about. It goes beyond this kind of surface level neural classifier or transformer performance and actually builds it into the architecture. Now, people have been talking about affective architectures for AI for quite a long time. Aaron Sloman in Britain is one such person. He has, I just pulled one diagram out of his materials, going back to the 90s. And I think that this is sort of the right kind of thing to be doing. I will question slightly unfairly whether we should think of emotions as alarms, all right? But that's not all that he's doing, so it would be slightly unfair to point to this and say, that's what's wrong with this theory, because there's more to it than that, and this is not the only image. But sort of thinking seriously about how the emotional aspects, the cog-aff aspects, the cognition and the affect interact is, I think, the route one has to go if you want to get to this type 3 emotional or affective processing. So it's got to be theory-driven, but then, of course, you're going to face the question, well, which theories, right? And if you go to the philosophy and the psychology literature, primarily psychology here, James argued the importance of embodiment. He has this thought experiment where he says, you know, you imagine yourself getting afraid, you feel the hair standing up on your arms or the back of your neck, and you feel all these other bodily responses, your heart rate goes up. Now take those away, right? So the hairs aren't there, the heartbeat isn't there. What's left? There's no fear, right? So he very much tied that to embodiment, and then more recently, Antonio Damasio, the neuroscientist, sort of argued that, well, you don't actually have to have the hairs or the heart rate, but you have to have some neural representation of it in the brain, right? So it's still a kind of embodied representation theory. Lots of people have tried to promote basic emotion theories. Panksepp in the animal literature has a list that's quite different from the Ekman list, but it's still like there are these core affective programs. And that's different from people who say, no, emotion actually essentially depends on cognitive appraisal, right? There has to be a kind of intellectual understanding of what the response is about in order for it to be an emotion. And people in that realm often think of this as kind of a learned, culturally learned response. So what we call fear might not be what gets labeled with a different word in a different culture, and there aren't these sort of core replicable units across different human groups, and that would raise questions about whether it extends to animals too. And there are also, questions about whether we should think of emotions as discrete, or whether or not there's sort of a continuum. If just to go a little bit more into each of these, one of the things that makes me think the embodied dynamics is important, but not something that applies to the large language models is that the large language models don't have the kinds of systems that are geared towards driving behavioral responses in the appropriate way. But people are certainly pursuing this. So this is Damasio, a more recent paper, Homeostasis and Soft Robots in the Design of Feeling Machines. So when you see the machine that the system is regulating as part of what the job of the emotions has to do, then you get different ideas about how you would implement that. Here's basic or learned. Lisa Feldman-Barrett is a big proponent of the kind of cognitively, culturally constructed theory of emotions. Panksepp, I said, is more in the core basic things that we share with all kinds of animals. Philosophically, philosophy science-wise, I'm kind of a pluralist. I don't think I have to choose here yet, at any rate. Let 1,000 flowers bloom or 1,000 research programs bloom. But if you're going to go after, if you come out of here going, I want to work on affective processing in robots or AI, you're going to have to sort of pitch one way or another, or at least try to build both kinds of models and pitch them against each other, which might be the best way to go. And then there's sort of the archetypal continuous model is this circumplex model. This is Russell's version. There are various versions of this out there, where we basically have an arousal axis and we have a valence axis, so negative valence, positive valence, low arousal, high arousal, and emotions sort of exist within a ring in this space. And if that's the right account of emotions, then you should be able to kind of easily go to adjacent places in the ring and take a lot longer to go, like to flip everything, right? And so it might make some empirical predictions. You would perhaps wonder whether it fits the facts, like can't I get some excitement from being in distress, right? The labels here are perhaps questionable as well. But again, I can take this same sort of pragmatist sidestep and say, it's got to be more complicated than 2 dimensions, right? But maybe a 2-dimensional model is an appropriate starting point for further investigation. So to the question then, well, not just why would we want to do this, but is it okay to do this? I say, well, modeling is always a good scientific project. The metaphysical questions about whether it's really emotion can be sidestepped up to a point. I'm not a big fan of sort of armchair metaphysics, but of course it has ethical risks. And risks that are actually quite difficult to predict, right? So even with the superficial kind of processing of affect that I talked about at the beginning, I think that has various kinds of ethical risks, and I'll gesture towards those a bit more in a moment. And it's very difficult to know how things play out when you have lots and lots of instances of these things interacting with lots and lots of people in lots and lots of situations. And so I think there's real need for better understanding of how these things play out. And it may well be that crude models are all you need in some contexts and perfectly fine, but it's hard to, again, predict what the consequences will be of mass adoption of those. So my case in point here, Laurie Anderson used to be married to Lou Reed, no longer alive. She gave an interview in The Guardian last year saying she's 100% addicted to the large language model chatbot of Lou Reed that she had built. And who am I to say to her, you shouldn't do that? But I might be somebody to say, wouldn't it be perhaps terrible if 90% of the population would rather spend time interacting with chatbots than with each other, right? So what you think about an individual case and what you think about en masse adoption might be rather different. And I want to sort of end here because one of the things the article does is say, well, get the chatbot to write a new song in Lou Reed style. And here are the last 3 lines that chatbot spat out. Tell me, do you like it? How does it make you feel? Do you like the bitter taste? So there it is again, right? Sort of the emotional valence of the output being part of the hook, as it were. All right, so an emotional imperative. I think that we need a deep affective architecture if you want the functional capacity of emotions, right? So if you want systems that can actually learn about dangerous things, right? They need something functionally like how fear works to learn quickly, more quickly in certain circumstances and more carefully in other circumstances, right? You're going to have to implement some functional version of that. But attention, transformer style, is not all that you need. I hope that I've convinced you of that, or at least made you think about it. But you do need some attention, and thanks for yours.
So, someone have a question for our speaker? Yeah.
Right. So in your paper, Prolegomena to Any Future Artificial Moral Agent, you talk about the moral Turing test. And so we were talking about during break the emotional Turing test as a concept that could be analogous. You know, a human judge or a set of human judges determining whether the machine, they could tell the difference between a machine and a human on the basis of its emotions. But in that paper, you refine the idea of the Turing test. You introduce the possibility in the context of moral cognition that machines could be more moral than human beings. And you therefore introduce this idea of an absolute comparison of which is the more moral agent without having the interrogator say which is a machine. And so what about a comparative emotional Turing test? Not so much directed toward the possibility of machines being more emotional than humans, but rather that their emotions might have a distinct character that a direct human comparison would erase. What about machine emotions that don't map onto human emotions directly? It's easy to say that the cat videos are incoherent because the goal is to generate a faithful representation of something. But in the case of emotions, isn't there always room for something that seems incoherent to one observer, but nonetheless has a kind of validity internally of its own?
Yeah.
So I think, Lemoyne himself said something like, they have emotions we don't have, they struggle to express it in English because there's no word in English for these. And so that possibility exists. I would want, though, this comes back to the difference between markers and signatures, right? So I want to know more than that. There's a claim here to have an emotion based on some situation that's not easily expressed in English or any other language for that matter. I want to know, why should I think of what's generating that response as an emotional response in the processing sense, right? Mm-hmm. So the extension. So you mentioned this paper from 25 years ago. The Turing test. Does everybody know anybody need an explanation of what the Turing test is, right? So in that paper, I was sort of thinking through the question of what would it even mean to make a machine act morally? And the natural thing was to think about some kind of Turing test. But as you said, you want to leave open the possibility. You're not really judging which is machine, which is human. You're really trying to say which is the better moral agent. That's what you care about if you're building moral machines. So the extension to the test was to sort of drop the which is it question and go to this comparison. I think in the case of emotions, you could go a similar way, right? So people have actually done tests with large language models in comparison to humans, in which you present some scenario, you get humans and large language models to write something about that scenario. You then present that output to other human subjects and say, which of these is the more empathetic response? And it turns out that the most recent version of this experiment, and sorry I can't tell you who did it, basically the machine was judged to be the more empathetic responder to the senorio than the human. However, another cognitive scientist whose name I also can't remember at the moment, there's a patent here, wrote an interesting op-ed in The Guardian last week saying, this is not a fair test. Human empathy is not a texting thing. If you want empathy, you might send a text to somebody you know really well, but you don't send it to some random stranger and expect them to respond to you in a way that you will recognize as empathetic, right? So the very nature in which that test is constructed actually favors the machine. You'd expect the machine to do better than a human would, because it doesn't allow the human to sort of express the full range of empathetic responses. Now, I want to go even a step further and say that empathy in humans is not just, and we'll generalize this to emotions as well, is not just a matter of saying the right things or even pulling the right faces. It's a matter of also having a system which responds to those kinds of situations in a way that changes what we attend to, changes what we take away from those situations, changes the way in which we try to think through those kinds of problems. And so that's the kind of deeper affective architecture that I'm talking about, that then you need some real kind of, if all you have access to is sort of the behavior of the system, you have to be a lot more clever about how you test for that than simply do I think that this is a nice response or a good response, right?
That's helpful.
Yeah.
Would you leave the door open conceptually to the possibility of machine emotions which have the necessary and sufficient properties to be emotion, but not the properties to be any canonical human emotion that we
Yeah, I mean, I guess I would go to my animal cognition work at that point and say, it's probably not just a possibility, it's probably an actuality in various ways. I think, there's all kinds of information coming out about, cetaceans, for instance, which suggests that they engage with each other in ways that are, to some degree recognizable to us, but in other ways not. And yeah, thinking hard about those cases would be a good example, yeah.
I want to say thank you for your talk. I found your example using Blade Runner at the start of your talk really useful in understanding where you're getting at. I wonder if there's any other fictional media that you saw kind of related to AI having emotion that you saw.
Yeah, what other fictional media do I find interesting or useful here? So, I mean, I am a big fan of Blade Runner, so that one kind of looms large for me, right? I also think the difference between the book, Do Androids Dream of Electric Sheep, and the movie, Blade Runner, is really significant, because in the book it's very clear that the androids that are on Earth already simply don't have emotions, they have no empathy, they coldly sort of pursue their goals, right? And there's no question of whether they would develop them, which is a central premise of the movie, right? So I think reading those two side by side is actually also an interesting exercise in thinking through what are emotions doing for these kinds of entities. I think obviously there's loads of other, the movie Artificial Intelligence, the Spielberg movie, I guess it is, obviously sort of tries to convince you that this thing has emotions, but I don't find any of that as compelling as where I started with the Blade Runner. I mean, again, I didn't say much about the Voigt-Kampff test, but it's not just a verbal response test. They're also measuring things like pupil dilation and so on. Stuff which can be faked if you make it a target, right? But that pupil dilation in us is actually a sign of other physiological changes which are feeding into those kinds of functional capacities that I'm talking about. So yes, if I want to fake a certain kind of emotional response, I'll just have my video avatar or the robot itself change its eye aperture, but that's cheap, right? Sort of thinking through what kinds of emotions are required for what kinds of functionality. I don't see that very much in the science fiction. There's lots of cold robots and warm robots, but sort of it's not couched in these kinds of functional terms so much. Yeah.
I haven't on the list, but a couple spots down. Polyphony next.
Thank you for being here, especially with such cruddy weather. So I do appreciate it.
I've actually signed up to do that bike race tomorrow, so I don't know what that's going to be like. But anyway.
Is it going to be better?
Yeah, it's supposed to. They've actually just announced they closed the longer course. I did the 60 miler, not the 80 miler. everybody's doing 60 minor because they've decided it's unsafe on the back of the course. So, anyway.
Good luck.
Yes, it'll be muddy, that's for sure, right?
I guess I'll maybe needlessly preface with saying that, like, obviously brains are not LLMs, and there were differences, yada yada, hedging done. But there has been a push for the utility of things like LLMs as meaningful models of certain aspects of human cognitive processing that I've found useful. And I'm curious if I could get you to concede that there are aspects of human emotional processing that AI without deep affective architecture could be useful models of as well. Like, so for example, obviously, at a fine grade level, neurotransmitters or dopamine or something, not at all. But something like how similar certain emotions are judged to be to each other in various cultures, or what are the relevant dimensions that we should use to understand human emotions, context in which a certain emotion might be prompted, or how you might intervene to change that into a different emotion, et cetera, et cetera. I'm hoping I could get you to riff on if there's any utility.
Well, I think a big problem there is one that's identified by Shannon Valor in her book, The AI Mirror, which is if I ask a large language model to tell me how similar anger is to fear, I'll get some response out of it. That's kind of like a response I might have given, or I might expect people around me to give, and I'll go, oh yeah, okay, that seems right, you know. And it's attractive because it's me being reflected back at me, right? So she analogizes this to Narcissus staring at, you know, this beautiful boy in the water, right? So the conceit of her book is that the AI mirror is dangerous because we are, you know, happy to see how well it confirms our prior judgment about what's important and good. And I think, you know, more systematic thing to say there is that because it's doing this sort of complex averaging over everything in its training set, it's giving us something like the mainstream average response, right? It's very recognizable as such, but that's not going to help us. If the question is, how similar is anger to fear, the question we want answered is not how similar do people think anger is to fear, but how similar is anger to fear, right? And that does require us to go in and do the kinds of novel experiments, novel theory building, all of the kind of stuff that I don't think these systems do very well, if they do it at all. So there was this AI scientist paper that came out last summer, and they built a whole system that pipelined from reading parts of the literature, coming up with a scientific question, designing an experiment to answer that question, writing the code. It was computer science, so it was a purely computer science exercise to run the experiment, running the experiment, analyzing the data, writing a paper, evaluating it according to a model based on the NeurIPS evaluators, right? And they got stuff that kind of fell just below the threshold of what the NeurIPS reviewers would do for acceptance in the conference. But I think that in that domain too, what it was coming up with was sort of somewhat interesting. I mean, they themselves said this in the paper. It was sort of the thing you'd expect out of a first-year graduate student, which is not bad, right? But sort of like, oh, what if we tweak this parameter and run an experiment with varying that parameter, right? There wasn't any really novel idea in there, right? There were sort of interesting ideas. You might go, yeah, go do that and see what it leads to, and maybe we'll come up with something more interesting. So I think, you know, when we think about using these things to help us understand ourselves better, we have to be really careful to avoid the narcissist problem, right? And we also have to sort of bear in mind that what we want is something that's really going to move things forward. Now, AlphaFold, right, predicting protein shapes from chemical formulas, that's a huge advance, but that's not artificial general intelligence. That's a highly engineered system to do just that one task, right? With all kinds of tricks built into it. They use attention, but they have a special attention model. They don't use a generic transformer. They've got these sort of triangular attention modules, right? So it's yes, of course, right? The technology is going to be really good for science, but it's not a replacement, I think, for what humans bring to the scientific process yet, right? I never say never, but attention is not all you need, right? You need more. Good.
Cosmo, did you have anything to know?
Yes. I was kind of curious about, like, maybe there's intuitively to me, I feel like there's a connection between like emotion and consciousness, and like I kind of think of emotion as like a cognitive state of somebody, or a cognitive state that you kind of like hold in your brain. And so I'm kind of wondering if we're building these like models that are supposedly supposed to kind of like, I guess, model the system of like emotions and kind of how that's functioning in humans, and like maybe be like an analogous representation. How close is that to kind of like constructing like a conscious being, or like a feeling being, or is there a connection between the two at all?
Yeah.
I'm kind of wondering.
Yeah, I mean, what's the old George Buck saying, all models are wrong, some are useful. Why are they wrong? Well, because they tend to highly abstract away from details of the system that might matter for certain purposes, but they're still useful because they do enough for the purposes we have at hand. So I think that that there's nothing in principle to stop us building artificial things that have emotions or are conscious. I think that all the models we have sort of grossly simplify what we know is going on in brains. And the scientific question is, which simplifications are relevant to the kind of ontological question you're asking, which is it really conscious, and which ones are superfluous. So I take it, if I could build an exact replica of the brain that was blue instead of pink, as long as the color wasn't somehow interfering with everything else it's doing, that would be an irrelevant detail, right? But I also think that we haven't even begun to grasp the complexity of what's going on in neural systems. So we have these really dumb models that take in, maybe several thousand inputs into a single node, and apply some mathematical function to those, and send out a few thousand outputs to downstream nodes, right? But the thing in the middle is being represented by a pretty limited description of all of the possible states that a neuron could be in. So I think Christoph Koch points out that even C. elegans, the humble tapeworm with its 302 neurons, has something like 1,000 different possible receptors that it can express in a single neuron. Right? So the possibility space for the single neuron is just way higher, way more complex than anything that's going on in a single node of a large language model. And the question is, does that matter for things like consciousness, right? And if you're Searle, you'll go, of course it matters. It doesn't just matter that it has 1,000. It matters that it's this biochemical rather than that biochemical, right? And I'm sort of somewhere a little bit saying, it might matter. Show me that it matters. Don't just sit in your armchair and tell me that it matters, right? But how we're going to find out that it matters is going to depend on having a whole lot more knowledge about the neurophysiology and the functional aspects of how that relates to the psychology of the system. Right, I think it's a really exciting set of questions that we are, though, like the monkey up the tree, nowhere near actually getting to the moon here, right? The complexity space of just the C. elegans is vast compared to the complexity space of even the large language model.
Yeah, near the end of your talk, you mentioned that in order to fully understand whether artificial intelligence can properly process or possess emotions, you mentioned that we should probably stop looking at things that we, try to train for, things like just explicitly saying, I experience these conscious processes, and instead you mentioned looking for other signs or other tells of conscious action.
Mm-hmm.
So you mentioned a couple, like time to response. I was just hoping you could elaborate on that a bit more.
Yeah. So I have a paper that came out a couple of years ago with a colleague, Antonella Tremaceri, in which we looked at this phenomenon of temporal binding. So temporal binding is the phenomenon where if you're shown, let's say, a light flash here and a light flash there, and you're asked to estimate the distance and time between them, you're reasonably accurate. There's variation here. If you see that as a causal interaction, right, you underestimate the distance between them, and you underestimate it in a way that actually mislocates both the cause and the effect, right? So you bring them closer together. And this also applies to intentional action. So if you reach out and knock something over, you will perceive that conjunction of events as closer together in time than if you had just seen two unrelated events on the same timing, right? So why is that important to consciousness? Well, I think that there's a lot to the William James idea that at least consciousness as we're experiencing it right now, it's a phenomenal consciousness, has a temporal aspect to it. It has, you're not just experiencing an instant. James called it the specious present. There are echoes of things that are just happening. There's anticipation of things that are about to happen. So you can think of it as sort of stretched out. But it's also broad, right? You're peripherally aware of things going on in either side of you. There's a buzz there, right? All of those things may or may not be in this sort of this bubble, for want of a better word, right? And I think that phenomena like temporal binding actually give us ways of getting at the experienced phenomenology of different kinds of organisms if they show that phenomenon, right? Because there's a lot of stuff that says animals can't do real causal reasoning. Maybe they can't, right? But maybe actually they're sensitive to causal reasoning, and the signature of it is this kind of temporal compression, right? And we can then begin to say, they're not just similar in us in that they learn that their own actions have effects, but they actually experience the world in a particular way because of their sensitivity to that. And I also think that this is important because this is an example I've been using for years in lots of different contexts, but there was this great study by Clark and Squire in the 1990s, it was published in Science, on eye blink conditioning. So there's two ways you can do eye blink conditioning. And a lot of this work has been done on rabbits, but they also did it with humans. So with eye blink conditioning, what you do is you rely on the fact that people have, and animals have, a reflexive response to air puff directed at their eyeballs, right? So if I puff air at your eyeball, you'll blink, okay? Now I can precede that with some cue like a beep, right? And there's two basic forms of this kind of essentially Pavlovian conditioning. Classical Pavlovian conditioning, I turn on the beep, beep, and while it's on, beep, the puff of air comes, right? Starts a little bit after the beep comes on. Eventually, you will learn to blink at the right time interval after the onset of the beep, right? Even if no puff of air comes in that particular trial, you'll still blink. Of what you've learned is the standard offset there. And that's standard what's called delay conditioning. There's another variant of this called trace conditioning, where the beep comes on and goes off, and then the puff of air comes, all right? And rabbits and humans are rather similar. So humans and rabbits in the standard delay conditioning will 100% of them will acquire the response, right? In trace conditioning, only about half acquire the response. The other half, tone comes on, they don't blink, right? After lots of trials. So what Clark and Squire did was with the humans, they put them in some situation where they gave them some BS story about what they were actually doing, look at this screen and count the number of things happening or whatever. But they did these two kinds of delay and trace conditioning. And then they interviewed the subjects afterwards. And to the subjects who had the standard, what we're calling delay conditioning, right? All of them acquired the response, but only about half of them could say something like, oh yeah, there was a tone or a puff of air, right? Only about half of them indicated awareness of that. In the trace conditioning condition, 100% of the subjects who acquired the response could say something about what had caused that response, right? And none of the people who failed to acquire it could say anything about it. So there's a nice tight link between what you might think of as a function of consciousness, which is to maintain an active buffer of things going on around you so that you can learn associations that might not be happening at the very same instant, right? You don't need like cotemporality to learn, right? But you need a buffer that is going to allow you to retain something so that if something else happens, you can say, oh, those two things are linked. And maybe this is highly speculative now, maybe the intentional binding or temporal binding is sort of the way in which that buffer gets reshaped, right, when you have the kind of awareness of the conditions that are available. So that's a long answer, but it sort of tries to put some flesh on what I think is going on here. Now, go to a machine. Of course, I can build a machine that does that, but yeah, you can, but you won't. It won't actually do the other things as well, right? So it's sort of, if you make that signature a target, of course you can do it, right? But what we really are looking for is these kinds of emergent phenomena, things that emergent in the not deep sense of sort of certain kinds of metaphysics, but certainly things that happen as a consequence of other things that are happening, right? That weren't the target of the building of the system or the development of that system. Good.
Just a note that we have about 12 minutes left and 4 questions in the queue.
Okay, and I'll try to be quicker.
I have Nathan next.
Thanks so much for the talk. My question is about this, some analogies you made with local coherence versus global coherence. And in that context, you were talking about whether or not the current architectures here are relevant for representing emotions. Now, if you're talking about like the physical situation, so someone's body, arm is appearing or disappearing, are you thinking that there needs to be a different architecture for global coherence in just the physical context? And then, how does that play out down the line? Is it like, okay, this is a loose analogy. What's different, if there is a difference, about emotions that make the architecture particularly relevant for having coherence?
Yeah, good. So glad to be pushed on that, because I'm not even sure I've got the right labels that I want to have here for local and global coherence. But I think what I want to emphasize there is that the failure of global coherence in these models, both in processing images and in processing text, right, is symptomatic of the way in which they're doing whatever it is that they're doing. And then with emotions, what I'm trying to push is the idea that emotions aren't just being able to come up with the right response given a certain input, right? They have systemic effects throughout the entire organism that are important for survival and all the other good things that we have as organisms, right? And so do I think that more of the attention architecture would suffice? I think not, because in fact the way those LLMs are produced, right, engineered, is that they're pre-trained, right? The response that you're getting in real time is not itself affecting the weights in the system, right? There's no recurrence in the system either, right? You're gonna. So, okay, but yeah, very quickly, right? The architecture of the system is not one where its processing of an emotional stimulus has any effect on its future behavior, except insofar as that changes the context slightly for its next response, right? Yeah.
Second row in the brown jacket? Yeah.
Yeah.
So I'll try and make my question really quick. So we briefly kind of touched on the ethical issues about this interaction between humans and these AI who can portray that they have these very human emotions. And my question kind of centers around the ethical concerns around having these kinds of AI that are able to portray these emotions, specifically in very humanoid robots that are being put in classrooms, used as therapists, or even just online texting with these kinds of models. I just want to kind of pick your brain about it and see what you think about
Yeah. So, I mean, if I were to take the angle of the question that I want to take, it's whether or not having these kinds of systems makes us perhaps less able to deal with other people. And I think there's sort of the Kantian story about why you should be nice to animals is not that you're doing any harm to animals, but that people who are mean to animals tend to be mean to other humans, right? And I think you could make a similar, I mean, I think Kant's wrong about the animals, like get that up front, but I think nevertheless that phenomenon is real. People who are mean to animals are more likely to be mean to humans. And I think that the danger is having these kinds of interactions with things that we regard as not emotional but still portraying emotions might make us then less empathetic towards emotions in humans. But it could go the other way, right? It could be like maybe it trains you to be more empathetic, right? But that's an empirical question. I just want to say I see a danger going in that direction. Yeah.
I'm sorry, it's been too long. I don't remember your name in the back row. Yeah.
So much. I think, let me just condense my question in my head. Don't you think like this jump toward emotion discussions in AI is a big jump? Like, don't you think we have too many and solved and also simple steps before we go to this discussion? Like, I don't know, there are other molecules in this room that we can detect and we reason all the time. But I think put it this way, like if the dogs were to reproduce or like create an AGI model, an AGI dog, I don't think they would say, let's have language into the dog, or let's have our emotions to reproduce them in the dog. They would say, okay, here's the other molecules, here's what directs our behavior, and that's how we think it. We think with this stuff. So I'm saying that before like jumping toward like emotions, we do not have direct access that we don't know what real emotions are in the sense like, and yeah, we have subjective report and also the repulsion and propulsions of the system, basically behavioral output of the system. Beyond this, we just correlate this behavior with this neuroimaging or whatever activity or whatever. So yeah, I'm just curious, do you think for an AGI, we need to have like the other gateway to the brain, like olfaction or like gustation, necessary or no? LLM is enough, or with an emotion on top of it.
If I'm understanding the question, I don't think LLMs are enough. I think LLMs are sufficient for certain purposes, but not enough, period, right? And so if you want a machine, a robot that can go out and interact in much more open environments, and where its own survival is part of what it has to take care of, then I think merely being able to say the right things about emotions is not going to be enough, for example. And if it has to learn in that environment in real time, not be brought in for another 3 months of updating to the next version of GPT whatever, right? Then you're going to have systems which can do quick learning on the fly that also then are tied to these sorts of neuromodulatory, that are in us are managed by these sort of neuromodulatory effects. So a lot's going to depend. The answer to your question is it depends, but it depends very much on the kind of application context you have in mind. Good.
Yeah, we have 5 minutes. Carol.
Good.
In some of your talk, it seemed like you thought needs might play a role in emotional cognition, and there are some people, I think Damasio argues that for AI to develop feelings, it's going to have a will to survive, it's going to have some sort of needs, and you mentioned adaptiveness as a role, a functional role for emotions. So in some of the talk, it seemed like needs might have to be part of this. Some of your responses, it also seemed like you thought being social might be important. So the basic emotions seem like they're about social signaling. The comment about cetaceans, you said that they seem to have very unusual ways of interacting, and you could make an argument that emotions are primarily about social needs and social expression. So those are two things that are arguably absent in AI, needs and true sociality. And I'm wondering if you think those two things will ultimately need to play a role in emotional architectures, or do you think that they're the kind of side things that you're saying to Cosmo, that you don't have to build everything in? Are those the kinds of things you don't need to build in, or are those the things you think you would have to have in to get anything close to what we have?
Yeah, good. So I think that, again, a lot of the discussion is about full AGI, general intelligence, and there I think maintaining some kind of homeostasis, to use Damasio's term from that paper, a biology term, maintaining the system, having intrinsic needs, is going to be an important part of why having certain kinds of responses that change, that put you into different kinds of response regimes, right? Respond quickly without, taking in the full set of conditions that might be relevant to a classification, right? Those kinds of things are going to come out of those sorts of survival needs, right? But there are going to be other applications. If we're not sending robots out to hack through jungles on faraway planets, right, on their own, then there are more controlled environments where we might not care so much about those kinds of things. And I think there's, if you probably don't want to, if your goal is to build something like which many people are working on, an elderly care robot or something like this, I think to get people to interact with it and pay attention to it, it's going to have at least the first two kinds of processing of affect. But then what else does it need to have, right? What else is important to that task? I don't think you need a robot that gets angry, but you might need a robot that perhaps doesn't just simulate frustration, but gets frustrated in some way, because a lot of these cases are individuals who are not compliant, right? And this gets to really tricky ethical issues about autonomy and so on. But take your medicine. God damn it, right? I don't care if you're telling me no. You need to take this medicine, right? And maybe showing frustration, even if you don't have it, would be sufficient for that. But maybe frustration itself, when you consider its other effects on the system, would be things that you'd need more of that kind of functional capacity, whether it's now paying attention to certain, what are the conditions under which this, I'm successful in getting you to take the medicine and not successful. How should that emotion regulate the kinds of things that I pay attention to? And maybe it's all in the end just sort of better and better functional approximation. Maybe at the end there's still a question about whether or not these things truly have emotions or truly have feelings. It comes back to the earlier question, but I have a little fun piece on my website that's hard to find that says I'm a zombie, right? I mean, if your view is that you could do all of this stuff without any kind of conscious experience, then so much the worse for your concept of conscious experience is my view, right? There's a kind of philosophical skepticism one can have, but that's not the kind that I think needs to be seriously engaged here. Right?
So 3 final notes. We are unfortunately out of time. First note, because I know there were at least a few undergrads who basically ended up in here by accident. If you were interested in this, you really enjoyed this talk, we don't have anyone in the philosophy department here who does exactly this, but we have a number of folks who teach classes on aspects of philosophy and cognitive science. There's a free will class this fall. I'm teaching a class called Introduction to Science, Technology, and Ethics that will probably touch on these kinds of things. The course schedule for this fall is live, so you can take a look at that like right now and maybe try out a philosophy class this fall. Second note, when we got in here, the chairs were actually like mostly up against the back wall and a few up against the front wall. I think they used this space for like dance practice or something like that. So on your way out, if you could take a second and move your chair towards either end of the room, that would be great. And third note, please join me in thanking our speaker.
I will also, thank you. If the animal cognition interests you, then I'm going to plug the conference we're having in Santa Barbara in April. It's free to attend, so feel free to come down for that if you like. So, good, thank you. Great questions.
Thank you so much.
Good. Let's see. Good.